What if I told you that you could be able to sort all verbs in a past tense form within the Brown corpus based on their frequency count with a few commands in a single line? At first I know it doesn't sound that simple, but in fact it is simple if you use a couple of very powerful bash tools, the most important of which is grep. And grep stands for Global Regular Expression Print. And what it does is that it finds or searches for us all the instances of verbs, in our case scenario, all the verbs in a past tense form, based on a search pattern that we will define. And the search pattern for us is the pattern that is related to the past tense form tag within the Brown corpus. A few words about the Brown corpus. As you probably already know, the Brown University Standard Corpus of Present-Day American English, or just Brown corpus, is a corpus of 500 sample tags of American English that has been tagged with part-of-speech tags. And these tags represent grammatical categories attached to each word. Let's have a look at one of these texts. First of all, let's go to a folder where I stored all the texts in the Brown corpus. As you can see, actually these are 506 texts. Let's have a look at one of these files. Let's take the last one, this one. Let's just open. Okay, as you can see, each word is followed by a / and then a part-of-speech tag. Our case scenario is that we would like to focus on the verbs in the past tense form, and the first thing that we would need to do is to search for those words that are followed by a / and then by the tag VBD. The VBD tag stands for or represents the verbs in the past tense form. Let's go and use grep now. So grep is the name of the command. Then I usually add the option n, which will give me the number of line where the resulting match is, and then I will have to specify the pattern, the search pattern within quotes. Search pattern here is the VBD tag, and then I will have to specify the place where the searching will take place, and that is within the current working directory. And more specifically, I want to search all the files within the current working directory. And now it will output the results in the standard output, which is the terminal. And as you can see here, it gave us back all the lines with verbs in their past tense form, as you can see. Let me clear the screen. I can redirect the result to a different file so that I can further explore this file. The output of the command will be output in the matched.txt file. Let's have a look at this file. As you can see, it's exactly the same result that we saw earlier, but now it is stored within the matched.txt file. Okay, so what else can I do? I can do the same thing, but now I can simply ask for the number of resulting matches. So here I know that I have 37,388 matches of verbs in a past tense form. I could do that by using the pipe that redirects the output of the command on the left as input to the command on the right. So the WC now counts for us the number of lines whereby the resulting match came out. The last thing to note is that in the beginning of each matching line, you can find the file name, then the line number, and then the whole line where the match appears, right? In this case, we have the polished VBD string, okay? Notice that the match in the previous grep search that we did was the line that included these 4 characters and not the whole verb, right? But if you'd like to focus on the matched verbs and print only the matched parts of a matching line, and also suppress the prefixing of file names, and also omit the line number, you would need to do a couple of things. You need to add a couple of options. Let's see how we can focus only on the matched verbs. So in that case, I would need 2 different options. The option O, that prints only the matched parts of a matching line, and the option H, that suppresses the prefixing of file names on the output. I also omitted the N option, as you see, for excluding the line number in the output. So the next argument is the argument that includes, in this case, a regular expression, and this regular expression matches every sequence of alphanumeric characters up until and including the /VBD character sequence, okay? And then one more word boundary. So what this regular expression means is that find every sequence of alphanumeric characters that follows a word boundary, and then is followed by these 4 characters, and then by another word boundary. And where would I like this search? Again, on the current working directory, okay? And now, as you can see, we have all the verbs extracted from all these 506 text files. Okay, but what I promised you is to sort all these verbs based on the frequency count with a one-liner in Bash. Let's go and do that. Let's first clear the screen and also change the command prompt so we have more space for the commands. And now, first of all, we want to take the output of this command, use pipe, and then sort the verbs that I found in each line. After that, we want to find the unique and count these unique lines. Uniq compares adjacent lines, so each time it finds the same word in the next line, and then it counts it, right? And writes a copy of each unique input line to the output stream in our case. The next pipe needs to include a sorting command. In that case, it's going to be sort, and then we need 2 more options, the option N and R, so that we can take decreasing order of frequency counts. And then let's take the first 30 in terms of frequency counts, okay? Now, as you can see, we have the first 30 more frequent verbs in the Brown corpus. And the most frequent verb is the verb said. It appears 3,476 times. And among these 30 most frequent verbs, the last one is moved with 276 appearances. So I hope you got a first good taste of the Bash power and what you can do with it. And I also hope you're intrigued to learn more about it.